I had started this problem, got interrupted. So going back to it, in a separate video, we have the function f of x is equal to the square root of x plus 1. And we want to find out what the derivative of that function is. And so we go ahead and we apply our limit rule for it. And now, if we look, we have the problem that we have two roots in the denominator, or in the numerator. So we are allowed to multiply the inside by any number we want. And so I'm going to choose to multiply it by 1. And I am going to multiply it in such a way that what we do is we change these roots to squares. So the only way to get that is the difference of two squares. So I need the conjugate. The conjugate of that is x plus root, or x plus delta x plus 1 under the root, plus root x plus 1. So we're going to multiply both top and bottom by that. And when we do that, this is equal to the limit as delta x tends to 0 of delta x times all that stuff. So x plus delta x plus 1 plus root x plus 1. But on the top now, we have the difference of two squares. And so that eliminates the radicals on top. And we're left with x plus delta x plus 1 minus x minus 1. And so we've got x and a negative x that cancel out. We've got a 1 and a negative 1 that cancel out. And we are left with a limit as delta x approaches 0 of delta x divided by delta x times the quantity root x plus delta x plus 1 plus root x plus 1. And we cancel the delta x on top and bottom, so that what we get is that's equal to the limit as delta x tends to 0 of 1 over root x plus delta x plus 1 minus root x plus 1. So we do that, then we get x, or the delta x tends to 0 as delta x tends to 0. And I made a sign error here. This should actually be a plus. So that equals 1 over 2 root x plus 1. That is the derivative. And so we can say that when f of x is equal to the square root of x plus 1, the derivative, f prime of x, is equal to 1 over 2 root x plus 1. Now this involves a technique that we don't use very much, but it is very handy to use when you're dealing with radicals, and that is the idea of using the conjugate to rationalize either the numerator or denominator. In this case, it was the numerator. So don't forget about those little techniques that we rarely use.